Hello, class. I'm doing a recording for one of your co-rec lessons. It's the lesson 3.1. It's called Introduction to Decimal Numbers, and it's on page 36 of your co-rec. So I'm going to share my document camera with you. And what you will need is your place value chart, which is called Roman numeral page 10. And it's your place value chart, and you can use this as a reference. When we take our quiz covering the sections 3.1 and 3.5, I believe that's quiz number 4, you are allowed to have this place value chart out as a reference while you're taking your quiz, okay? And you'll notice on the place value chart, we have the decimal point, which is called the AND decimal point. And to the left of the decimal point, we have our counting numbers here, or you can say whole numbers. They start with 0. But in your place values, you have ones, tens, hundreds, and then thousands, 10,000s, 100,000s, and then millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions, and then we stop there. There are other place values beyond that, but we stopped at the trillions. And on this counting side, counting numbers, natural numbers, it's a comma after 1, 2, 3. So 1, 2, 3, comma. You have a period. 1, 2, 3, comma. Another period. The thousands period. 1, 2, 3, comma. The millions period. 1, 2, 3, comma. The billions period. And then if you have numbers beyond that, 1, 2, 3, comma, if you have numbers beyond that, that's the trillions period. Then we have the small decimal side. There are no commas used on the decimal side. And notice how it starts or it ends with a THS. On the natural number side, it just ends with S. But on the small decimal side, it ends with a THS, tenths, starts with tenths. So this side starts with ones, but the small decimal side starts with tenths, tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions. And then we stopped there on the billion side, but they end in THS, and there's no commas used on this side, okay? All right. So if you look at some of our problems here that start on page 36, it says lesson 3.1, introduction to decimal numbers. So it says to write a fraction as a decimal, we want you to divide the numerator, which is the top number of the fraction, by the denominator, which is the bottom number of the fraction. In other words, make use of long division, and take care to note where to place the decimal point in your answer. So we want to write the fraction as a decimal for 7, the fraction 7/10, and they want you to show your work for full credit. So you want to note that the 7, the top number, goes inside the long division house. This is 7 divided by 10. Okay. And when you ask how many 10s go into 7, right? 10 is called the divisor. And that should be, you know, at least 1. The divisor should be, right, at least 1, which is 1 or more, right? And it should be a counting number. So it should be at least 1 and a counting number, like no decimals, right? Okay, at least 1 and a counting number. And the 7 here, this is called the dividend. Okay, 7 is called the dividend. So how many 10s go into 7? None. So you write a 0. Then you should add a decimal, and you should pull it straight up. And then you should have another 0 here. And you say, well, how many 10s go into 70? And that would be 7. 7 times 10 is 70. Because remember, this is 70 minus 70. Because remember, this decimal actually got brought up to the top. So this is 70 minus 70, which is 0. And I'm going to put a little r there for a remainder. Remainder, r stands for remainder of 0. And so when you change the fraction 7/10 into a decimal, it's 0.7, which read out loud, if you read that out loud, that's read 7/10. So you can read it out loud as a check, 7/10 as a check, but you do have to show your work. And when we take this quiz, this is the quiz. Quiz number 4 is where your teacher is going to be checking that the student, you need to demonstrate that you do know how to do long division. You want to make sure you set it up correctly. To set it up wrong, this is wrong. To write it like this, to write it like that is wrong, where you put the 10 inside the house and the 7 outside for 7/10. That's wrong. That's not correct. Okay. Also, you need to show your work. Sometimes students do this, 7 divided by 10, and then they use their calculator and they just write that, but they leave like their work missing work. So, you don't want to be missing your work. You need this work in here. That's what your teacher's checking for, all of that. This is the setup. So you want a good setup, a correct, good setup, want a correct setup, and then you want to actually do your long division, set that up. Okay, all right. So this is 7/10 then, all right. For number 2, sometimes you'll have a whole number, we'll write the mixed number in decimal form. So this is 13 and 4/100, 13 and 4/100. So to write a mixed number as a decimal, you want to put the whole number aside and you want to perform long division on the fractional part. This fractional part right there, okay, of the mixed number. And then afterwards, then you want to add the whole number to your quotient to obtain your answer, okay? And then it says show your work, show your work. So when you set it up, your long division, the 4 goes inside the house. So remember the numerator goes inside I call it the house, the long division house, okay? And so it's 4 divided by 100, okay? So 100 doesn't go into 4. Like if you were to wear a size 100 shoe, you couldn't put that, that your foot into a size 4 shoe. It wouldn't fit, right? So how many hundreds go into 4? You say 0, okay? But then you can add a decimal point and pull it straight up and then start adding at least a 0, right? And you say, well, how many hundreds go into 40? Well, again, if you were a size 100 size shoe, you wouldn't be able to put that foot into a size 40 shoe. It still wouldn't fit. So you still need to put 0. Okay. And then you can, you don't have to multiply 100 times 0 is a 0. You don't have to do that. What you could do is just start adding another 0 there. And then remember that's 400 because remember this decimal got pulled up. So that's 400. How many hundreds go into 400? Well, that's 4 of them. 100 times 4 is 400. So 400 minus 400 is 0, and that's your R. Remember, R stands for your remainder. And so you have 0.04. And then just remember that, what you have is that whole 13 plus this 0.04. And so when you add when you add that up, you're lining up your decimals, 0 and 4, 0 and 0, decimal, 3 and 0, 13. So this is your answer. Okay. And this is read out loud. This is read 13 and 4 hundredths. So you read that out loud as a check. But remember, we want you to show your work. So we read this out loud, 13 and 4 over 100, right? 4 over 100, it checks out 13 and 4 hundredths, okay? It's just you have to show your work. We want to demonstrate to me that you know how to do your long division. If you bypass this, if you don't show me this, then teachers think, oh, they don't know how to do their long division. They don't know how to do their long division. And then you're not demonstrating that you know how to do your long division, which is a check. We have to check for that before you graduate from this class, that the student knows how to do their long division, for example, okay? And so again, the wrong setup, to set it up wrong, it's wrong to set it up this way. To put the 100 inside the house like that, and then just to say, oh, that's, to write somewhere up there that that's 0.04, just to use your calculator. That's wrong setup. That's not correct. That's the wrong setup. Alrighty, okay. All right, now, next. Okay, so this was our, and we boxes are circled, this was our answer. And we put this was our answer. Okay. All right, next, they want you to change the following decimal, this decimal, which is 0.5, which read out loud. This is read out loud as 5/10, right? If you read that out loud, 5/10. They want you to change this decimal to a fraction, and then if possible, reduce. And they want you to show your work. Okay, so this is how we're going to train you. This is how we want you to show your work. Here are your steps. There's like 3 steps. The first step, to convert a decimal to a fraction, we want you to start off with this definition or this format, decimal over 1. So start, with decimal over 1. So you're gonna show your work. So you're gonna use decimal over 1, okay? And then you're gonna sub, which is short for substitute. Your decimal in this problem is 0.5. 0.5 over 1, okay? And in mathematics, in math, okay, decimals are not allowed in fractions. Did you know that? You cannot provide an answer, submit an answer where you have a fraction that has a decimal either in the numerator or denominator. Did you know that? That's not allowed. Okay, it's not kosher. It's not kosher. It's not allowed. Okay, it's not cool. Okay, so what you have to do is you have to clear the decimals. Clear the decimal in the fraction by multiplying by a form of 1 expressed as a power of 10. So I'm saying this in other words. Okay, because at the top, if you look at your steps, if you look at number 2, it says multiply both the numerator and the denominator by the same power of 10 so that you're multiplying by a form of 1. And here are your examples and your limitations. 10 over 10 or 100 over 100, because that's also 1, or 1,000 over 1,000, because that's also 1, right? 10 divided by 10 is 1. 100 divided by 100 is 1. 1,000 divided by 1,000 is 1, right? It's a form of 1. And so, how will you know which form of 1 to use, right? Do I use 10 over 10? Do I use 100 over 100? Do I use 1,000 over 1,000, right? And in these exercises, I've never seen the system, you know, they randomly choose problems. I've never seen them where they go over, like they could have, but they didn't, like 10,000 over 10,000, 100,000 over 100,000. A million over a million. I haven't seen any problems with the computer randomly picks problems where you need those type of forms of 1. Usually you're always revolving around these choices, 10 over 10, 100 over 100, or 1,000 over 1,000. So it depends on the most number of decimal digits present among your numerator. So your numerator is 0.5, okay? And so that has 1 decimal place that's, you know, tens place. So you want to use 10 over 10. That'll do it. And so that will clear your fraction. So, you know, the way to multiply fractions, you know, is to multiply straight across. So if we multiply 0.5 0.5 times 10, that gives you 5. And 1 times 10 gives you 10. And you see how your fraction got cleared of decimals? See how there's no more decimals, whereas before it was 0.5 over 1. Now it's 5 over 10, no more decimals. And that's what you want, okay? And so then they want you to reduce. So we reduce by 5. 5 divided by 5 is 1. And 10 divided by 5 is 2. So that looks like that becomes 1/2, 1/2, okay? And as a check, when you read this out loud, you start off with 5 tenths. You see, there's your 5 tenths. And then you reduce it by 5, you get 1/2. This is a check when you read it out loud. But you do, for the full credit, you do need to show this word. You need to start with the decimal over 1, 0.5 over 1, and then show that you're multiplying by the form of 10 over 10, which is a form of 1. Okay, and that's how you show your work for these. And then, yeah, step 3 was where you simplify. You reduce the fraction if possible. Okay, so this says that the numerator will become a whole number. Okay, for example, two place values after the decimal point in the numerator, then you would multiply both numerator and by 100 over 100. If you have 3 place values after the decimal point in the numerator, then you would multiply both the numerator by 1,000. Well, 1,000 over 1,000, okay? So that's how you know you count your decimal places, and this just has 1. So 1 power of 10, 10 over 10, okay? Okay, so let's show you another one like that, and let's show you number 4. So when a whole number in front of the decimal is present, then convert the decimal portion to a fraction by putting the whole number aside and returning the whole number to the front to make a mixed fraction. After you've converted the decimal, after you convert the decimal to a fraction using steps 1, 2, 3, okay? So this, if we read this out loud, this is read out loud, 73 and 7/100ths. 73 and 7, that's tenths hundreds. Okay, 70 and 700. Just keep that in mind. Okay. And remember what you want to use. Remember, you want to use that vocabulary. Remember, decimal over 1. And then you're going to substitute your decimal part, which you're going to substitute this decimal portion, which is 0.07 over 1. And remember, fractions can't have decimals. You cannot submit that as like an answer, 0.07. Well, you can't have decimals ever in a fraction. It's not allowed. So you got to clear them. So you got to clear the decimals. And the way you do that is you multiply by a form of 1 expressed as a power of 10. So your choices are, do you go with 10 over 10? Or do you go with 100 over 100? Or do you go with 1,000 over 1,000? So you see how this, and that's why you read this out loud, 73 and 7/100ths. There's a clue there, hundreds. There's another clue here, 0.07. There's 2 decimal place values. That's 2 zeros. So that's another clue, enough to help you with selecting 100 over 100 as opposed to 10 over 10 or 1,000 over 1,000. And then the real check is, once you multiply across, the way you multiply fractions is you multiply them straight across. And you need to know that, because when we take our final, your final's cumulative, definitely on the final, one of those problems, you have like 25 problems on a final, you definitely know one of those will be multiplying 2 fractions. Okay, another one will definitely be dividing 2 fractions. Okay, so the way you multiply 2 fractions is you just multiply straight across, and then you just try to reduce them. So 0.07 times 100 is just 7. And 1 times 100 is just 100. Okay, and that cannot be reduced. 7's a prime number, and that cannot be, nothing will go into 7 and 100 besides trivial 1. But remember, this is not your answer. I'm boxing now, but this is not your final answer, because remember, you had the 73.07. So your answer is going to be 73 plus that 7 over 100. So 73 plus this 7 over 100, which is just 73 and 7 over 100. And that is your answer to this problem. Okay. Now, if you use the wrong power 10, you should be able to catch your mistake. Like, let's say you tried to multiply it by 10 over 10 instead of 100. Let me show you this. If you take, so 0.07 over 1, basically 0.07 over 1. And let's say you do times 10 over 10. Let's say you chose 10 over 10. You'll see that doesn't do the trick. That doesn't clear your fraction. 0.07 times 10 is 0.7, and 1 times 10 is 10. See that? So see how note how the 10 over 10 does not actually clear the decimal in the fraction. See that? So if you choose the wrong one, I said you can use 10 over 10 or 100 over 100 or 1,000 over 1,000. If you happen to choose the wrong one, you can tell because it didn't clear the fraction. Just remember, you cannot have decimals in a fraction. So this is going to be an issue. This is not complete. You would still have to do work on that, and you would still have to multiply that by a power of 10. Now you have to multiply that by another 10 over 10. So then you have to do more work. Now you'd have to take 0.7 over 10 times 10 over 10. 0.7 times 10 is 7, and 10 times 10 is 100 to get the 7 over 100. Okay, so next you have to do a lot more work. So you see, just using the right one from the get-go takes care of that. If you go overboard and use 0.07 over 1, if you use the 1,000 over 1,000, that also creates an extra step because I think you'd have to do an extra reduction. So if you do this, you'd have 0.07 times 1,000, which is 70. And then 1 times 1,000 is 1,000. And then you'd have to reduce that. So you know how you can cross out in zeros on the end? And then that would give you 7 over 100. Then you get to the 7 over 100, but after you reduce. So there is always just one that's just right. See, that just when you multiply across, you get 7 over 100. This one, it didn't do the job, it didn't clear it. So you have to multiply by another form of 1 and a power of 10 to clear it. This one you went overboard, so now you have to reduce. But in the end, we can all end up with 7 over 100. It's just these take extra steps, where this one just gets it done. And then you still have to remember on all these, don't forget to add the 73. Sometimes students just say, oh, the answer is 7 over 100. And I don't count it all off. I give you partial credit, but you can't get the full credit because the real answer is 73 and 700s, okay? All right, so now on the bottom, so in one of the things about, showing your work is we want you to, and we're more than halfway through getting ready to take a cumulative final, right, in a few weeks, right, in the semester. The other thing is remind you to demonstrate, do you know how to multiply fractions? That's another thing, do you know how to multiply fractions? So this definitely requires you to show that, right, demonstrate that. And then does the student know how to reduce if possible, right? So, you were on this one, you were showing this one had to be reduced, right? Over here, this can be reduced, right? Reduced by 10 or every 0 on the back. For every 0 on the top, on the end, you can cross out a 0 on the end, only on the ends. Okay. Okay, now we're getting to rounding. Rounding. Remember that they want you to make use of the wavy lines. See these approximately equal to wavy lines for expressing approximately equal to when you're rounding numbers. That's a courtesy to the reader to let you know that it didn't end up exactly like that. You did some work on it. You did some rounding work. So for these 5 through 8 problems, include the approximately equal to symbol on your rounding work. What you'll do is you won't be able to put the rounding symbol in the computer. You'll put it on your paper. So in your paper, I'll check for that. That'll just be like worth a point. Like if it's something that's worth 4 points, that'll be a point for that approximately equal to symbol for rounding. So this one, you want to round the decimal to the nearest hundreds, okay? So that's where this comes in. If you want to, you can label this in your place value chart 1.25. So 1.25734. And you're being asked to round to nearest hundreds. So this is tens, hundreds. Okay, so you're unboxing the 5 in the hundreds, and then you're looking at the neighbor, the number immediately to its right, its neighbor, looking at the 7. Okay, so I'm going to do that here. I'm going to box the 5 that's in the hundreds. I'm going to look at the neighbor. And the question is the neighbor 7 at least 5, right? That's the big question, yes or no? And you can say, yeah, the neighbor 7, yeah, that's 5 or more, 5, 6, 7, yes. Okay, so then what do we do about it? So what you're gonna have to do is you're going to have to add 1 to the box digit, which was 5. You're gonna have to add 1 to the box digit 5. So above that, I'm gonna put a +1. And then 5 plus 1 is 6. And then this is just a 2 decimal point 1, and then approximately equal to, okay? And then that would be it, because this is tens, hundreds. This 6 is in the hundreds place. So what you want to do is you want to stop recording digits to the hundreds. We want to stop recording digits to the hundreds place. And so the 7 and 3 and 4 zero out, but don't include the zeros in your answer. So don't do this. Approximately 1.26 and then a 0 for the 7, a 0 for the 3, and a 0 for the 4. Don't do that, because when you do that, then you're recording to the tens, hundreds, thousands, 10,000s. Then you're recording that to looks like the 100, tens, hundreds, thousands, 10,000s, 100,000s. You're recording to the 100,000s, and they don't want you to record to the 100,000s. They only want you to record to the hundreds, tens, hundreds. So better for you. Let's work for you. You can try that. If you try that on your homework and pay attention to your work on your homework, see what happens when you type that in. You'll notice it will mark it wrong, or it won't let you proceed. It says you can do something better. Are you sure you can fix that better? Okay, so pay attention when you make mistakes on your homework. Pay attention to that and learn from that so that you don't make the same mistake on your quizzes. Okay, all right. Number 6, round the decimal number to the nearest tens. 10. So if I go back again, 3.42198. If I were to read that out loud, that would be 3 and then the way I would read this is I would kind of do like, I would say like 42,000 with a D, but then I'd say 198 hundred thousandths with a, that's where I bring the THS, 100,000s THS, okay? So 3 and 42,000 with a D, then 198 hundred thousandths THS is how I would read that out loud in words if I had to write that in words. And you're rounding this to the nearest tenths, which is right here. This is the nearest tenths. And you can look at the number to the right. Is that, 5 or more, okay? So I'm gonna, on my paper, I'm gonna box the 4. I'm bringing it to the nearest tens. And then I'm gonna do this. I'm gonna do point arrow this way to the 2. That's my neighbor. And the question is the neighbor 2 at least 5, question mark. And you would say, no, that 2 is not, is that at least 5 or more? No. So then what happens is do not add 1 to the box digit. Do not add 1 to the box digit. To the box digit 4. Okay, so that means that the 4 will stay the same, and then decimal, and then 3, and then approximately equal to. And then this would be your answer, 3 4/10. And yeah, these just disappear. Those become zeros, and you don't record them as zeros. You don't write them. You don't record them with the zeros because you want to stop recording. You want to stop recording at the tens place. Okay, so this would be wrong to do this 3.4 and to put a 0 for the 2, a 0 for the 1, a 0 for the 9, a 0 for the 8. That would be wrong. They don't want you to do that. Okay. Okay, next, round the decimal number to the nearest thousands. Okay, nearest thousands. Okay, so I have 2.1 and then a 9 and then 964. And you're going to nearest thousands. So tens, hundreds, thousands. Okay, and then you look at the neighbor. The neighbor is 6. Okay, so I'm gonna go to my paper, and I'm gonna box that 9, tens, hundreds, thousands. I'm gonna draw an arrow to that 6. Okay, and the question is the neighbor 6 at least 5? And you would say yes, 6 is at least 5. So what are we going to do? We're going to add 1 to the box digit, which is that 9. Okay, and then it will involve some carrying, because when you add 1 to that 9, it turns out that 9 plus 1 is 10. And then you're going to have to carry 1 over to the next number, which happens again to be a 9. So you have a little bit more carrying, because 9 plus 1 is 10. And then you're going to do another set of carrying. So you're going to add another 1. But then that's where the carrying stops, because you see there's no more 9s. Now this is a 1, and 1 plus 1 is 2. And then you see you have your little decimal point, and then you see you have 2. Okay, and then you have your approximately equal to. So this is approximately 2.200. So this is tens, hundreds. See, that is thousands. Tens, hundreds, thousands. Tens, hundred, thousands. So 2.200. Tens, hundreds, thousands. Okay. And these, the 6 and 4, yeah, they zero out, but you don't record those. So this would be wrong to put 2.200 and then put the 0 for the 6 and then a 0 for the 4. That's, no, we don't do that, because now that's tens, hundreds, thousands, 10,000s. That's going to be 100,000s. And they didn't ask you to record to the 100,000s. They didn't ask you to record to the 100,000s. Okay, they wanted the thousands, tens, hundreds, thousands. Okay. Okay. Now, those are all rounding to the, on the small decimal side, on the decimal side. Now, this one's going to be a little bit different instructions, because you're rounding on the counting number side. So this one's going to be a little bit different. The previous ones, we were all rounding on the small decimal side. This one, we're rounding on the natural number, counting number, whole number side over here. So this is 172,743. 172,743. Okay, and we're going to round the following number to the nearest hundreds, Okay, so we have ones, tens, hundreds, right? It's at the nearest hundreds, right? Nearest hundreds, ones, tens, hundreds. Okay, and then you look at the neighbor. There's a neighbor 5 or more, right? Okay, so we're boxing this 7 right here. So let me do this over here. 172,743. And it's ones, tens, hundreds. Okay, and then you look at the neighbor. And the question is the neighbor 4 at least 5? And you would say no. So then do not add 1 to the box digit 7. All right. So then the 7 will remain the same. And then comma 2, 7, 1 approximately equal to, right? Okay, but then this is where your instructions are different, because we're on the counting number side. We're working to the left of the decimal point, so the instructions are going to be a little bit different. So the 4 and the 3 will become zeros. The 4 and the 3 will zero out, and you do want to record the 0. So why? Since we're on the how did they word it? We're on the counting natural number side. We do record the zeros for that 4 and that 3. So that 4 and 3, that zero out, you do put the 0 for the 4 and you do put the 0 for the 3. You do that here because we're on the counting natural side. Because if you don't do that, this is our answer. If somebody doesn't do that, then they think that this is 1, 7, 2, 7. Then they think that that's that. If they don't put the 2 zeros, they think that's that. They think that's 1, 2, 3. They think that's 1,727. That's wrong. It's not. When you estimate 172,743, you estimate that, you round that to nearest hundreds. It's going to be 172,700 to nearest hundreds, ones, tens, hundreds. This is only 1,727. So you see the big difference between 172,700 and just 1,727. So this is, you have to be careful with that. Okay. Okay, so those are my lecture notes for this section. Just to remind you that you do have practice problems, so you're always welcome to work on your practice problems, like on page 38. And then you have your answer key and your correct that you can check your own answers. And then you also have like a little practice quiz. You're always encouraged to work the practice quiz. The answers are in the workbook. To quiz for, this would be quiz 4, I believe. Quiz 4 covers 3.1 and 3.5. Okay, so good luck with your homework. And so just remember, on your homework, on your own pad, even though I don't pick up your homework, you should trust that you're doing your homework, you know, the way we're showing you how to do it in the lecture. So I trust that you're showing your work the way we've been showing you in your lessons. Okay. All right. Good luck with that.